Python loops are not efficient for performing operations on large datasets. Now, this in part is due to the dynamic and interpreted nature of Python, and then the fact that Python types are flexible. So, the sequences of operations they cannot be compiled down to efficient machine code, as in languages like C, Fortran, or C++. Now we're going to run through a quick example to demonstrate the slowness of Python loops. And then we're going to see how we can bypass this by using vectorized operation. Later on, we're going to be talking about vectorization and ufuncs in Numpy. Ufuncs is universal functions. They allow us to perform vectorization in Numpy. We're going to be getting into all of that later on. But quickly, I want to show us how regular Python loops can be very slow for performing operations on large data sets. So let's get into it. We're going to create an array. So we're going to use Numpy to do that, and then we're going to define a Python function that performs operation on our Numpy array. So to do that, we can do import Numpy. You already know how this works now as Numpy. So that's our alias, np. So we're going to seed np.random.seed. Obviously, the reason we're seeding is for reproducibility. Okay. Now let's define our Python function. So def, say we want to get the reciprocals of the values in an array. So we can do def compute reciprocals like that. Of course, this takes an input. Okay, so we have value. Let's have values. Okay. Now let's set our output. We can output is np.empty. So of course, empty is a namespace in Numpy, and then we can get the length of our values like that. And then let's do the loop for high in range. Okay, and then let's use the length of our values in our range iterator values. Okay, I think that's accurate. So this is going to okay. Now we have let's get each item in our output. Let's set this to okay. Now the reciprocal 1.0 divided by each element inside our values like that. Now we can return output. So return output like that. So this is our Python function. This function is going to compute the reciprocals of every value inside our Numpy array. So let's break out of this function. Now let's set our values. Remember, compute reciprocals is expecting these values inputs. So let's set our values there, values. And then for values, we can do np.random.randint. Okay, so let's set our interval 1, 10. We can set our size to be 5 like that. So that's our values. Now let's invoke these compute reciprocals and let's see what we get. Then we can do compute reciprocals and then we have to pass these values in here. So when we pass this, now this is a NumPy array. The size is 5. The range is from 1 to 10. So when we pass this in here, this Python function will fire and then compute the reciprocals of each of the values that we have here. So if I pass values here, enter, okay. So we get the reciprocals of the values inside this NumPy array using this Python function. Now, the slowness of these is not quite apparent at the minute, because when you look at the data, we are computing the reciprocals of 4. We realize that the size is just 5, which is quite small. Now we can deal with, we can do the same operation, we can perform the same operation for a larger data set. And then from there we can see just how slow this approach is for such operation. So what if we did, say we did big array, and then we set this to np.random.randint, and now we go from 1 to 100, which is our interval. And then we set our size to 1 million. Size 1 million. For readability, let me do this. I think Python interpreter should be able to ignore that and just interpret this as 1 million. So that's our big array. This is going to be the array that we're going to work on now with this compute reciprocals Python function. And this is performing a regular Python loop. Okay. Now we can now do, okay, the other time in the course of our tutorials, our series, I think prior to this time, when we did Python tutorial series, Python for Beginner series, we mentioned the time profiling IPython magic method known as timeIt, which gives us the time of execution for a Python statement. So we can use that here to get the execution time for computing the reciprocals of this large data set. It's quite large because the size is 1 million, and then we have an interval from 1 to 100. So we can do timeIt. Okay, so when we do timeIt, then we can invoke our Python function, compute reciprocals. And now for the values, we're going to pass this big array in there. And then if this runs, we should get the time it takes to perform the operation. So now we can do big array, okay, which is going to be our values in this case. Now if we press enter, see, it's taking time, it's taking time, it's taking time. See, it's taking time. Let's see. You see how long it's taking? You see, look at how long it took before we even got an output. I hope this demonstrates my point. So now we get 2.54 seconds plus or minus 3.8.7 milliseconds per loop. The mean standard deviation of 7 runs for one loop each. Look at how long it took to perform this operation. Now, NumPy gives us a way out of this, which is to perform vectorized operation. Vectorized operation is the kind of operation that we perform on an entire array elements without explicit Python loops. So we're going to be talking about broadcasting later on. Broadcasting is the mechanism that allows us to perform vectorized operation across arrays of different shapes and sizes. Of course, when we discuss vectorization, we're going to be talking about ufuncs as well. Ufuncs is a universal function. It's a universal Numpy function, which handles operations like these efficiently. Now, in Numpy, we can bypass this compute reciprocals function, which is doing this in a normal Python loop way. So we can just bypass this compute reciprocals entirely. Well, the data we're working on is big array, which is this. So which means we can just do something like this. We can do, what is it? We can do time it. Let's do time it. And instead of calling this Python function, we can just do 1.0. Since we're computing the reciprocals anyway. Okay, let me put this inside of parentheses. Then we can do 1.0 divided by big array. That's it. And let's see. Let me press enter. See? You realize this is faster compared to what we did the other time. Now look at the time it took. The same operation, 3.92 milliseconds, where this was 2.54 seconds. 3.92 milliseconds for plus or minus 16 microsecond per loop, microsecond, significantly faster than this millisecond. Then mean plus or minus standard deviation of 7 runs, 100 loops each, even though this was performing 100 loops each as against 1 loop. And look at the time it took to do this. So guys, I hope this demonstrates to us the slowness of Python loops. In subsequent tutorials, we're going to be diving deeper into this concept so as to drill the understanding of it into us. Okay, I'm going to stop here and then I'm going to see you the next video.